so that you know that. So hi, Isaiah and Charlotte and Jordan. I wonder if JP's going to come up for this one because he's a real bat guy. Okay, so it's 1:32. So welcome everyone to our second session with Lannis about bats. And I know that some of us have done this session before, but Lannis always has new facts and new information and things to show us about our about the animals that she has at the Leslie Nature Center. So we're going to turn it over to her. Hi, Delore. Nice to see you. And we will learn together about bats. And Lannis has been really good for me, boys and girls, because I used to be really nervous around bats, but now I have a healthy respect for them. I know, and I'm so excited to see them because they are really useful creatures and sometimes I guess would have had a bad reputation, but now we know that they're helpful creatures to our ecosystems. So I'm going to turn it over to Lannis and we're going to meet some of her friends. Hi, Dawson and Elise, and we're going to learn about bats.
Wonderful. Awesome. Thank you. And hello or welcome back to those that have seen some of my workshops before. I am always excited to be back here and share some of the cool things we have within our center. I'm located in Ann Arbor, Michigan, and I'm actually standing inside what's called our critter house here at the Leslie Science and Nature Center. And that's mostly because most of my job revolves around taking care of the animals that are housed here on our site, both native and non-native to our state. But then that means the really cool part is that I get to share with folks like you some of these experiences in meeting some of those live animals up close. And as mentioned, which I know you're all excited about, we are talking all about bats. While there are over 1,200 species of bats out there in the world, we will have time to talk about most of them, or at least ones that are common, and we'll get the chance to meet 3 live bats up close. One that is native to the majority of our regions, and then 2 non-native species, just to give us an overarching look at really the diversity of bats since there's so many. The cool thing is that we actually find bats on every continent except Antarctica, just a little cold there, which also means how they survive, those features or adaptations we talk about, are also going to be very different depending on what they eat or where they live. But today, you're also going to learn that at least the 3 bats that we meet today kind of have a job, or at least a role, something they do to help other organisms, including us humans, in their ecosystem, which is why we always consider bats to be so important, even if we don't see them all the time. Now, many of you probably already know that we share some similarities with bats. We, like them, are mammals. We have these really big furry bodies. I know I have a lot of fur on my head today too. We're warm-blooded. We stay one temperature no matter where we are. Our body is that temperature, whether we're outside in February, March, or August, we stay that, just like bats. But from there, that's kind of where the similarities stop, at least for the most part. Many of you probably know that bats are considered to be nocturnal, or that they're most awake, at least at night. That's when they prefer to eat. We might also know that bats use something we call echolocation, which, while not all bats have it, we usually talk about that in relation to sound. Don't worry, we'll get into it in a little bit, I promise. Or, better yet, you bet you know that bats are the only mammal that can fly. There is no such thing as a flying squirrel. Even though they're named that, they really just use big flabby armpits to glide from one tree to the next. That's about it. Bats are the only mammal that can sustain flight, which also means how they're built, their structures are really unique in order for them to not only continue to fly to look for food and other resources, but also to have enough energy to do so. The really cool part, though, is that we do at least share some type of structure that helps bats fly, even if we can't use it to fly, and that's these hands. In fact, a bat's wing is actually their entire hand. Here, if you look at the bones of a bat, this is actually kind of the skeleton or side view, and you look at the size of their wing. All of their bones inside this wing structure are actually your finger bones as well. If you look at this, you can see the top part here, that's their thumb. And then all the way down the edge, that there's incredibly long pinky from the pinky finger. But the really cool part is, if you see how big it is, notice that it covers or is the length of the bat's entire body. Meaning if we were bats and we could have the same hand wings, if you will, as bats could, our hand and fingers would have to be the entire length of our body too. That'd be like giving each other the biggest high five in the world. But the really cool part is that then scientists actually call bats, their scientific name means hand wing. That also means how their wings work are the same as how our fingers work. Here's what I mean. Try this. If you have one of your hands, try just sitting here and taking your fingers and moving one finger at a time without moving any other part of your hand. Pretty easy, right? Yeah. See, we humans, we have a lot of flexibility. We don't have to move all of our fingers at the same time. We can move one after the other. Well, bats, they can do that too. They can take their wings and they can move sections of them because they can move their fingers the same way we do. This allows bats to take their wings, fold them around and spin in the air, or to help them flip upside down and grab something by their toenails. Or many bats can actually take their wings and help them change their direction instantaneously by folding or moving different parts of their fingers, all thanks to the skin connected in between. In some ways, that means they can even fly better than some birds can too. But it's all based on how they're built. Beyond that, being able to fly also allows them just to travel farther distances. Many bats, even ones that live in Michigan, they migrate or travel to different locations, either depending on temperature or possibly food. And being able to travel long distances also helps with these bats' job. Now, I know there are some folks saying some really cool things in the chat room. I love it. I'm going to do my best to make sure that we look through the chat room here and there to try to answer your questions about some of the bats or bat facts that we talk about. I do know I did have one question already. Somebody asked, where do fox bats live? That's a really cool question. There are some really large bats that we call flying foxes, mostly because they look like foxes that can fly. Many of them live in Southeastern Asia or in New Zealand. That's just a much more tropical or warmer place where they can find a lot of their resources and allows them to get to be so big. In fact, the largest bat in the world is a flying fox. It's called a Malayan flying fox, and its wingspan is up to 6 feet long. That's taller than me. Think of how crazy it would be to have bat wings that big, or at least finger bones that long. But today, we are going to meet some bats that are related to those flying foxes. In fact, the first bat we're going to meet is what we call a mega bat. Now, flying foxes are mega bats too. I know, isn't it crazy how big they are? But this mega bat really just means that it has bigger or larger features. And most mega bats tend to eat or be found in similar habitats. So let's do this. Let's go ahead and meet our first mega bat, understand where it lives and how we know it's a mega bat to begin with. And then let's see if we can figure out its job. Now, don't be concerned about the word mega. It's not as big as a Malayan flying fox, but I bet you'll find some bigger features compared to maybe the bats that live by us. We here in Michigan, at least, we have only small bats. We call them microbats. Pretty fitting since micro means small. Most of those bats are insect hunters, where while they're smaller, they're able to feed on a large amount of insects. Well, megabats tend to have a slightly different diet. Here, he's right next door, so I'm not leaving you yet. We'll see if not only we can identify him as a megabat, but I'm really curious to see if folks can also see different similarities between this kind of bat and maybe the ones that you find even around your house. While there are two distinct types, mega and microbats, they do still have things in common. All right, ready? Here we go. I'll make sure I stand back so there's a little more room because he's a little on the larger end for sure. And the first thing I usually hear from people is that this guy looks like a dog or a puppy. Even people call bats sky puppies. And yes, I do find that a lot of people think they are cute. It's mostly because megabats tend to have these really long noses. Now, megabats usually have larger features on their face. For example, a longer snout, That's because they're mostly fruit-eating bats. This guy loves to chomp down on watermelons and mangoes, cantaloupes, papayas, even avocados, berries, other fruits you could find out in its own forest. It also, though, has incredibly large eyes. Now, that's key because while we said bats are nocturnal, many bats rely on sound, something we call echolocation, to help them navigate or find food. This guy doesn't do that. This kind of bat does not echolocate, mostly because he doesn't need to. Being a nocturnal animal, this guy can rely on his large eyes, or his eyesight primarily, to find things that he needs in the dark. And since his food isn't really going anywhere, fruit doesn't usually move or walk away, it's a lot easier for him to navigate or find his food via smell and sight rather than sound. However, all bats, including megabats, have these really large cone-shaped ears, and that way they can still take in all of the little sounds around them, even if they don't echolocate. You can actually watch he moves them all over the place. It's kind of like little radar, or how we take our hands and put them behind our ears, we kind of create cones too, and it's a little easier for us to hear. Somebody even noticed that he can see his teeth, and you're right, it's actually really easy to see this guy's mouth, and that's one of the reasons we have this bat. For folks that have ever attended a workshop with us from the Leslie Science and Nature Center, you might have learned that many of the animals we have some kind of injury to where they can't be released into the wild. This guy is not native to Michigan. He's a Central African species living in a very tropical habitat. However, and somehow he got into some kind of accident, bumped his lip, and has a permanent lip injury where he's lost most of his teeth. Just means it's harder for him to eat different kinds of fruit. So while we have to be careful to make sure he's able to eat the things we provide, we know that he wouldn't be able to find all the food or easily eat it that he would need to if he was out in the wild. That's why he's with us as a teacher for you guys to learn about these kinds of bats. The kind of megabat, this straw-colored fruit bat that I have, is usually named that way because you can see these yellow lines along his back and belly, almost like the color of straw. However, when we look out into the wild for these guys, we usually don't find just one. These are one of the bats that migrate or travel hundreds of miles looking for different kinds of fruit. And usually when you see these guys, you don't see one, you see hundreds. This is a picture full of straw-colored fruit bats, all migrating to one forest at once. But usually traveling in numbers is pretty safe. Even if you're a giant bat like a megabat, it always helps to make sure you're outnumbering other predators that are around you, especially if you're flying around during the day. Now, I said that every bat we meet today kind of has a job. And this guy's job actually has to deal with how he eats, or at least what happens when he eats. For example, we said this guy is a fruit eater. Well, let's imagine for a minute that this bat eats a piece of watermelon, and let's say he accidentally eats a seed. Well, then what's going to happen to that seed? Is it going to sit in his stomach and it's going to turn into a watermelon plant inside him? No, not usually. Could he cough it up or throw it up? Maybe. But really, usually what happens is if these guys accidentally eat a seed, they will go to the bathroom and poop it out. And I know poop is kind of a silly word, not always scientific, but bat poop is actually so important, we put a name to it. We call bat poop or their waste guano. And here's the kicker. Guano is so good for plants, bat poop, that you humans, you can buy bat poop off the internet. That's right. Do you have a garden or plants around your house looking to find extra nutrients for them? All you have to do is buy a bag of bat guano and you're all set. And I know that's silly, but it's really important. Here's the thing. See, when bats go to the bathroom or when they shoot their waste and they have a seed inside it, that kind of acts like a built-in fertilizer. It has a lot of nutrients like nitrogen that those plants need to grow. And if you have hundreds of straw-colored fruit bats all eating fruit, accidentally eating seeds and pooping them out, think of how many fruit trees you're planting out in that one forest. This guy's job is to be able to take seeds, spread them or disperse them around different areas and give them nutrients to grow by, well, going to the bathroom. So this is key to make sure that our fruit trees, not only for him in the future to get more fruit, but for other animals to live in. Now, I already see a couple different questions about this guy. One that I see right away is, why is he awake? That's a good question, because most of the time when we talk about nocturnal animals, we would assume they're most awake at night. However, just because you're nocturnal doesn't mean you can't be awake during the day. In fact, these bats are kind of opportunistic. They'll kind of be awake whenever they want. It's a lot safer for them to be able to look for food in the dark, sure. But for this guy, especially since he's been around humans often, he kind of can choose to be awake whenever he wants. In fact, straw-colored fruit bats typically migrate or travel during the day, so they're still awake. And most nocturnal animals don't need as much sleep as we do. In fact, they might take naps or snooze, but that's about it. They can still be awake during the day, even if they're not as active as they would be at night. And that can kind of apply for most nocturnal creatures, while we still might see things like raccoons or possums out as well. Kind of confusing because I know they might be more awake at night, but they can still be awake during the day if they choose to, just like we humans as well. Good questions. Now, one more final thing. With this guy being a seed disperser, many fruit bats typically have that job. And so if we can think of any larger megabat or fruit-eating species like those flying foxes, they're great at spreading seeds out too, just because of their ability to travel thanks to being able to fly and the kind of food that they eat. So all good thoughts for this guy's job. Now, many of us, I bet, have probably read or heard of the book Stellaluna. That's a great bat book to understand mostly differences between birds, but also different survival techniques for bats. But what if I told you one of the bats that I had is actually the exact same bat as Stellaluna? For example, you guys, if you've read the book, you'll probably notice that it always talks about bats and birds, and while it looks a little smaller, this kind of bat we have next. The really fun part is there is always an exception to many sciences, or many facts we have in science, and this one's going to be one of them. This next bat, like Stellaluna, is a fruit-eating bat. It's a megabat, and we just learned that a megabat, like the one we just met, don't echolocate. They don't use sound because they don't need to. Fruit doesn't move. However, this is a fruit bat that echolocates. It uses sound. So as a scientist, I'm going to need your help. Why in the world would a bat that eats fruit or things that don't move need to be able to produce sound? Why in the world would it need to echolocate to begin with? This bat too, while being a megabat, is a little smaller and we actually hold it differently. So I'm gonna make sure folks can still see it easily in front of our screen. But let's see if we can figure out the better idea of why in the world this megabat, even though it eats fruit, needs to echolocate. Let's see if we can take a closer look. If I can get this guy back up here. Excuse me, sir. Here. He's a little smaller, so I still want to hold him in my glove appropriately for folks to see. Now, this guy we found is a little more comfortable sitting upright, even though most time we find that bats hang upside down by their toenails. It's purely based on every bat's training. So for this bat, his training, we learned that he actually is much better being able to see you guys or face our video screens. But this kind of bat, like Stellaluna, is what we call an Egyptian fruit bat. And while he's smaller, look, you can still see the megabat feature, his longer snout, his larger eyes, and larger wings. I know he does look small, but he's actually still pretty big for a bat. Who would have thought? Most bats that live here aren't even the size of my finger. But these guys are also an African species. They too can travel farther distances like our straw-colored fruit bat, but like I said, they also echolocate. Okay, so hold on a second. If you're an animal that eats fruit, you typically wouldn't need to use sound to be able to locate your food. So this guy, he actually echolocates instead, mostly to navigate around to find his home, or better yet, to avoid things like trees that are out in this forest. This bat is one of the many cave dwellers, or meaning its main habitat is inside caves. So from there, if you're going into a really dark space, and while his eyes are big, sure, he might not be able to see as well as our first bat. What he'll do is he'll make a sound like this. Listen. It's a tongue click. Tongue clicks over and over and over again. That's this bat echolocating. And what he's doing is he's signaling around to make sure that he doesn't hit any trees when he flies, or to make sure he can reach the center of a cave without hitting the edges and find other bats. So in some ways, they can use it kind of like a GPS, a navigation device, to find areas where they want to roost or nest too, not just to find food, like some of the bats that live here. Now, this guy's job is actually very similar, something some of you may have learned already. I got word that some of you were able to attend a pollinator or a pollination workshop. Well, did you know that bats are kind of like bees of the rainforest? They actually pollinate too. In fact, they're some of the main pollinators for different tropical plants. These guys too, because they're so big, they also can move pollen everywhere. Here, I need both my hands for this, so I'm going to give this guy a quick break. But I actually want to show you what this bat looks like when he pollinates. It's hilarious. See, Egyptian fruit bats, what typically will happen is they'll stick their noses, but mostly their entire body into the flowers of certain fruits or plants to where they look like this. This guy is completely covered in yellow pollen. He stuck his entire body into the fruit and flower, drank the nectar, and got pollen literally all over its body. But that's great. Being a pollinator is incredibly important because it means that you can make sure certain flowers, fruits, and plants can grow. So while bees are small and they're able to fly, sure, they can distribute pollen to certain plants here. But bats, because they're able to move farther distances and because they're just a bigger size overall, they can pollinate way more than any bee and most butterflies can too. But here's the kicker. This guy, this Egyptian fruit bat, he's actually a pollinator to a very specific plant. In fact, he's the only pollinator. There is this ginormous tree in Africa. It's called a baobab tree. We actually see it in the movie The Lion King. It looks a lot like this. And if I look at this picture, let's say we took a trip to Africa, I'm going to notice it's really the only tree in this habitat, the only tree in this space. That means it's going to be one of the only places of shelter for many animals that use this as shade or water. In fact, you humans, you actually use something from this tree. We have a lot of this fruit in our lotions or our shampoos, even our soaps, which helps make us smell nice and clean. But the fruit from this plant, sure, is eaten by a lot of animals, but guess who's the only pollinator? That bat. That Egyptian fruit bat is the only animal that pollinates this tree. Do you know what that means? Without Egyptian fruit bats, there would be no baobab trees. They wouldn't exist. All of these homes that they have that could live in this tree, or all of the fruit that we humans and other animals use, either for our shampoos, lotions, or food, wouldn't exist. So that animal's job is literally to make sure that there are baobab trees on this planet so that other animals, even humans, can use that to survive. That's why so many bats are so important and why pollination in general is important too. Not only when it comes to bees and birds, but even bats across the world as well. Okay, I'm going to pause for a second. We have been using this word echolocation a lot, but we're not sure if everybody knows what it means, or at least why it's important when it comes to bats. You may have heard of the word echolocation before too with other animals. Perhaps dolphins, even humans use it too. We call it sonar. But how it works, it's kind of strange. Here, I'm going to see if I can break it down for you because it's all about how sound moves. And too, for Katie and Molly, it looks like one of our folks might not be able to hear anything too as well. Just want to check to make sure that we can make sure Maddie can hear us okay. But all right, I see a lot of folks say they know, perfect. When we think about echolocation, the best way to think about it is how sound moves. Because right now you can hear me talking, but you probably can't see the sound coming out of my mouth. Mostly because we don't see sound. However, when sound is traveling through the air, it's actually traveling in a wave-like motion. You can even do the wave with your hands. And a wave-like motion over and over again until it hits something. See, let's take a look at this. Let's say our bats, you can see one right here in the middle, makes a noise. Well, that noise or that sound is going to travel in a wave until it, boom, hits something like an insect or what? Hits something like a tree. And the key part is that that sound has to bounce back. Once it hits a solid object, it's going to come back to the bat. That bounce back or echo is what the bat needs in order to not only figure out the location of this object or food, it can also tell how fast an object is moving, how big it is, or how far away it is from the bat, so that when a bat is looking for something like an insect, it can catch it on the first try. There's another object you can use, though, to understand how sound travels. It's actually an object we might all have in our houses or have at least used once, and that's this, a slinky. Slinkies are actually a great way to understand how sound moves because sound is also a vibration. If I held my slinky at either end and I just moved it back and forth, what happens is the slinkies, they move from one edge to the next and then bounce back to the other side over and over and over again, just like the echoes or waves when bats make noise. You can also try other sound experiments with slinkies too. Now, the final bat we're going to meet, I talk about echolocation a lot because he is an echolocating master. But that's mostly because not only of how he echolocates, but what he actually does with his ears to help him hear the sound. Now, I'll tell you this. When bats echolocate, most bats at least, sometimes the noise they make is too high for us to hear. So this bat, he may be echolocating while he's out and about right now. I'll see if I can pinpoint it out. However, we won't actually hear anything because the noise they make is too high for our ears to perceive. But we'll see if we can figure out how it works. This bat is also very common, not only here in Michigan, but also throughout Canada and most states in the United States. If you've seen a bat around, even by your house, this is probably the kind of bat that you have seen. Let's see if we take a closer look. He's also a micro bat, meaning he's just a little smaller, but I'll do my best to make sure folks on our camera can find him, especially while he's camouflaged. Ta-da! Now you might have to look a little closer, but he's our little furry blob right here on our log. And while he is a micro bat, he has just about the size of his body as my finger. He's a full-grown adult though. This is as big as this bat gets. And he's called a big brown bat. Bigger than his cousin, the little brown bat, at least. He's quite cute, I know. But here's the best part. I know we can't see his face very well, but microbats, unlike megabats, don't have very large faces. In fact, their eyes are almost so small, we can't even see them. They're there though. But what that means is then this guy doesn't rely on his eyesight. He primarily relies on echolocation to navigate and find food. Also, his ears are bigger than his face, so that way he can use his ears as his primary sense to also find other creatures or other bats. Here, this is actually the face of a big brown bat up close. You can see the really tiny black dot being his eye, but check out how big his ears are. They're these giant triangles hanging out near the back, and they're cone-shaped, just like the other bats we saw today too. Now, I said big brown bats are master echolocators, but here's why. Every so often, if you watch, you might even see this guy open his mouth, and that's because he's echolocating. But like I said, we can't actually hear it. Here, I have a device though that helps us figure out what it would sound like if we heard this bat. Sometimes different species of bats have their own way of echolocating, so that way we can tell them apart from each other. Listen close. I'm going to use a device called an echo-meter. It allows me to see what these bats would sound like if I could hear them as a human. And I want you to listen and see what you think they sound like when they echolocate. I have to make sure I press play though. There we go. Listen close. Whoa. Kind of sounds like a robot. Oh, there's more clicks. A little bit more. Awesome, it's very clicky, or it just sounds like a series of clicks over and over again. That's because it is. This guy's way of echolocating is emitting or sounding off a series of clicking noises, kind of like a robot, over and over to make sure that sound continues to travel. Look, even right now, he's opening his mouth a little bit. He's echolocating. Probably trying to figure out how big my computer is too, just by getting close enough. But here's the best part. It's probably a good thing we don't hear this guy when he echolocates. Why? Because this little bat is loud. He's really loud. He sometimes can be as loud as the smoke detectors in our house or the fire alarms in our schools. This one bat can make that noise. Think about it. If this bat was flying around outside and we could hear it, we would have to plug our ears wherever we went because it'd be just too loud for us to be able to take it. So thankfully, we can't hear him when he echolocates. But here's the weird part. As a scientist, when I think, okay, if bats are making noise, they probably have to hear that noise they make really well. Their ears are right there. They have a great sense of hearing. So then how in the world does this bat protect its ears from the loud sound it creates? Well, luckily, this little bat has another trick up his sleeve. You humans do have something else in your ears that helps you to hear. He has it as well. There are these 3 tiny ear bones called a stirrup, an anvil, and a hammer. They're deep inside and they vibrate whenever we hear a noise. But if we tried to sit here and we had thought really hard, do you think we could separate those ear bones, pull them apart so we couldn't hear anything? I could try, man, but it never would work. We humans just can't move the inner ear bones inside our ear. But guess who can? This bat. When he echolocates, as he's doing right now, you can see his mouth moving up and down. He can take those ear bones inside his ear and he can pop them apart so we can't hear anything at all. Here's how it works. When he makes a noise, a really loud sound, he'll push those ear bones apart using extra muscles so we can't actually hear the sound he makes. But I guess all he needs to listen for is the echo, the sound bouncing back, right? So don't worry. About 6 milliseconds later, he puts those ear bones back together so he at least hears the echo of the sound. And it's much quieter or much softer than any of the sound he makes originally. It's kind of like the best selective hearing of any animal you could think of too. And he can do it, well, as many times as he needs to. Now, these guys, when they are hunting, which is mostly at night, they're primarily nocturnal, they're amazing at catching a variety of insects. For example, this little bat that I have in my hand, we'll try to adjust him a little bit so that way you can see him. He can eat over 1,000 mosquitoes in just one night alone. But most often they eat beetles or moths, sometimes flies, even ones on the ground like small crickets or cockroaches too. But the funny thing is that what's great is we actually appreciate that or try to get more bats around our house so we can get rid of insects. This guy's job, if you will, is insect control, and farmers love little microbats. That's because these guys help them save money. Think about it. If you just had a bunch of bats around, all eating the insects on your property, you wouldn't have to worry about insects eating your crops, your gardens, your food. That means that farmers don't have to use chemicals that could sometimes kill off insects, sure, but maybe other animals as well. But if you have a bunch of bats around, no worries. Then you can rely on these guys making sure they get rid of the insects you don't want around your house anyways. Not that I would suggest putting a bat in your house to get rid of ants or fruit flies, but at least the insects that are outside, the ones that eat our own food too. That's why we try to attract bats, especially by so many farming areas, so that we don't have to use chemicals, sometimes harm other creatures, and it saves farmers tons of money too. Now, here's something to consider. Bats, unfortunately, as mentioned earlier, don't always have the best reputation, or sometimes bats can be in trouble. So then that means for us humans, we want to figure out ways that we can help bats too. I'm going to pause for a second though, because I want to make sure I check our chat room for any questions we have before we talk about what we humans can do. Ooh, I have somebody that says, can mosquitoes make animals who eat them sick like they can make us people sick? That's a great question. Well, these guys can get bitten by mosquitoes, meaning they can get an infection. And yes, there are some diseases that we humans contract from mosquitoes that other animals can too, including bats. One that we may have heard of is something called a West Nile virus, something that we can get from a mosquito bite. Bats can get it too. Not if they eat the mosquito, but if they actually get bitten by it instead. Bats can also contract other viruses we humans get. However, here's something to think about. Bats don't really get sick. Bats can get the disease. Bats can get a virus, but for the most part, they're actually able to get rid of it really quickly. What happens is bats have a very different immune system than you and I. They can fight off viruses and diseases really, really fast. And it's all thanks to the fact that they can fly. They have a really fast heart rate and a really fast metabolism. Ooh, there's some bat noises behind us today too. And because their bodies are always so warm and they're always working so hard, they actually get rid of viruses really quickly. The only one, there's two actually, that we hear of that are really dangerous to bats are something called white nose syndrome and rabies. Those, unfortunately, bats aren't able to get rid of. It can make them very sick, and usually a bat dies from those two things. Now, there are some things that we humans, though, can do to help at least save those. Somebody even mentioned in our chat room that bat houses are a great idea, and you're absolutely right. In fact, I have a bat house behind me too that we can take a closer look at, mostly because they're really easy to make or easy to find. This is actually just called a single chamber bat house. It's kind of like a little bat apartment. And inside it, It can fit up to 60 big brown bats, all in here. They're small enough to fit in the space and actually like to huddle together. They'll cling on upside down, and you can put this even right by your house, especially if you have a lot of insects hanging around. That way, not only do you attract these bats, but you give them an easy, safe, and warm space to live. And then you don't have to worry about those mosquitoes or other animal or insects flying around. I know, 60 can fit in this one alone. This is actually what they look like when they're inside the bat house, all huddled together, staying nice and warm and safe. It's pretty cute. But there are other things we can do too. One of the biggest problems for these bats is just habitats alone. What that means is usually bats that we find around our human areas don't always live in bat houses. Many times they look for ginormous trees. Most bats that live where we are aren't cave dwellers, just because we don't have a lot of caves. They actually live inside the bark of dead, decaying, ginormous trees. Well, we humans don't always find those trees to be attractive, so we usually cut them down. But that's actually a really important habitat for these bats, particularly when they hibernate. Bats don't hibernate in a bat house. It still gets too cold. So they look for other more natural spaces in the wintertime to hibernate. I see somebody asked, will they sleep there in the winter? Only in our more natural or enclosed spaces. Too cold in a bat house. That's why we try to learn a lot about bat habitats. That way, if you protect the habitats where they live, you also protect the bats. Somebody asked, can bats hurt you? Ooh, that's a really interesting question. Here's how I would frame it. Bats can bite like any other animal that has a mouth, even like myself, but bats will only do this if they get scared. Remember, we are one of the largest creatures out there. I'm the biggest animal sitting in this room right now compared to these bats, and it's my job to make sure the bats I work with feel safe when they're meeting new humans like you. It's also important to remember that bats can get really scared if they see humans out in the wild. So whenever we talk about seeing or exploring where bats live, or if you ever go looking for bats, you want to make sure that you observe them, but don't try to touch or hold any of them either. It just makes them really scared. Beyond that, bats will never hurt a human on purpose. It's too dangerous for them to, and they'd rather leave us alone, just like we would them. Really good questions too. That can kind of apply for a lot of other smaller animals or animals we might see or be fearful of, like snakes or spiders. Really cool thoughts. Now, I want to pause again because I know we're almost out of time. But I want to check in with Katie and Molly to make sure that they didn't have any other questions for us or see anything that I missed. Katie or Molly, is there anything else that you'd like to make sure we say today?
No, I think that you've answered all the students' questions as they were going along, as always. And Jordan, is that a question about bumblebees? Do you want to know about bats and bumblebees?
And bumblebees are pretty cool, don't get me wrong. They're great pollinators too, like bats.
That's right.
See a lot of our pollinators actually now, thanks to all these spring wildflowers that are blooming.
That's right. And we're challenged to go on like a scavenger hunt. Why is a big brown bat called a big brown bat?
That's a good question. Not the most original name out there. Funny enough, big brown bats are classified that because there is a bat that looks very similar to big brown bats, but it's just slightly smaller. So you actually have something called a big brown bat and a little brown bat. They look almost the same, except one is smaller than the other. So they classified them mostly to tell them apart by their size. Beyond that, those bats have no other color markings or no other different kind of fur camouflage beyond the color brown. So probably to keep it simple, I would assume scientists did that mostly to tell them apart by size. Good thought though. Sometimes the process in naming animals can get a little weird.
That's right. Absolutely. And I think that's it. Oh, C said how many names?
Oh yeah. We said we have two categories, our mega bats and our micro bats. The last bat we met, just to reiterate, was a microbat, mostly because of its size and that they eat insects, and most microbats echolocate. Whereas megabats, the first two we met, their eyes are far larger, they tend to have larger features overall, and most of them are fruit eaters. Hopefully that helps to give a better distinction of the difference.
Absolutely. Just knowing that one echolocate and the other one sees, like that's a really good way of classifying them, which we're always learning about from you, classification. So